Azul DevRel Espresso, brewed for Java minds.
Hello, and today we have another session. This time it's about AVD, which means Azul Vulnerability Detection. And my name is Gerrit Grunwald. I'm working for Azul as a senior developer advocate. And as already mentioned, today is all about vulnerability detection. So what is AVD? Well, it's a cloud-based security scanner, and it scans your JVM-based application in production, which is the big difference to other security scanners that you know. And it works with all the OpenJDK releases, so you don't really have to use only Azul, or you can use Tamarin, you can use Corrado, you can even use Oracle if you like. As long as it's built on OpenJDK, it will work. So why should you use this one and not another one? So I never said you shouldn't use another one. So let me explain why it is useful to use a security scanner in general. So first of all, this is your application, and usually your application has direct dependencies, right? So, and these direct dependencies, you can see them, they are visible to you because you have it in your build file usually. In the Maven build file or in the Gradle build script, you have something like dependencies, and then you see, okay, I'm depending on Spring Boot, whatever, right? Log4j. So, but now these dependencies have, again, dependencies, and these are so-called transitive dependencies. And then these transitive dependencies also could have more dependencies, and these are hidden to you, so you can't see them. And the problem is if some of those transitive dependencies are vulnerable. So how do you know, right? Well, like I already mentioned, the answer is security scanners. They are specially made for this kind of things, so they can scan your dependencies, your application for vulnerabilities, right? Which is nice. The question is, where do they work, right? So if this is the software supply chain, then usually, as you can see, we have a development. This is us, the developers, and then we pull in the data from a central repository, like Maven Central, for example. Then we push our own builds into our own code into our own repositories, and then we build it using a CI/CD build system, and then we create artifacts that we store in an artifact repository, and then finally it gets into production. And also from the CI/CD build, we drag in more dependencies from the central repository, and the artifact repository can, depending on what we are doing, also put stuff back into the central repository. So this is usually how it works. You will find similar diagrams, but this is in principle every time the same. So now security scanners can work directly in your IDE on your source code. That means in development, which is nice. So you will find plugins for Sneak or Sonatype or whatever. You can use it there. And then it can work on your repositories, which is also great. So you can scan repositories for vulnerabilities, which is good and which you should do. You will find security scanners that work in CI/CD builds, right? Which is nice. So that means you build your artifacts and then you can scan them. And also artifact repositories can be scanned by security scanners. Well, when it comes to production, that usually isn't really the best place to scan for vulnerabilities. And the main reason is performance. Because these scanners are quite heavy in using or testing the stuff. And if you would like to do that in production, it will drag down the performance of your application. And you don't want to really do that in production. So that leads to the problem of false positives, right? So that means if we take a look at the security scanner and it scans your stuff up to CI/CD, right? So then it suddenly, in the CI/CD build, it finds a vulnerability and then it stops the build. And the next thing it will do, it will mark the library that it found as vulnerable, right? And then it will be passed on a list, and then this list has to be used by a security person, and then this person has to check and verify if this vulnerability is used, right? And then the security person, after some time, figures out, okay, we never really use this library, so we are good. So we can flag this library as it's okay to use, right? That means we wasted a lot of time just because the CI/CD scanner assumed that that might be a vulnerability which is critical for our application and stopped the build. So what is the solution to this problem, right? So the solution could be scanning in production, right? So that means the CI/CD scanner assumes there is a vulnerability that might be critical. And if you scan in production, you can prove if the CI/CD scanner was right. So that means if we offer something like Azul Vulnerability Detection, it means we can prove that all your other security scanners that you use up to CI/CD are correct or not. Right? It's not a replacement, it's an addition to your software supply chain. So how does it work? So if you have your application running in a JVM, right, then usually what we do, we have an agent, a Java agent, and this Java agent can connect to the instrumentation API of OpenJDK builds. So that means of any build that is built of OpenJDK, we can hook up the agent to this JVM, and then the agent gets information from the JVM at runtime with a very minimum overhead. So let's say it's around 1% that it really brings down performance, which is more or less, you can really ignore it. And then this agent sends the information to something that we call the forwarder. And the forwarder is installed by your infrastructure team in your own infrastructure at some point, right? So the demilitarized zone or wherever. So your guys have to figure out where to place that the best. It should be reachable from the inside to the agents. And then this forwarder forwards the information from the agent to Azul Intelligence Cloud, right? So this is the main setup. The interesting part now is that we can run multiple JVMs with multiple agents. They all connect to the forwarder, and then the forwarder forwards the information. Why is that important? Well, if you have these days, you have setups with microservices in clusters, right? So it means you have lots of nodes running the same application. But if you would like to scan them all, it's a little bit tricky to do that in production, right? If you use this approach, then we can tag each of these microservices that has exactly the same application running with a tag like my application. And then this application will be scanned by the agents, the information goes to the forwarder, and then from there into Intelligence Cloud, where the Azul Vulnerability Detection will take place. And then afterwards, when you create reports, you can search for these tags. So that means you will find all the nodes that you have scanned that have the same tag. And that means the same application running in different nodes will be present in one report in the end, which is quite useful. So the vulnerability detection works as follows. So you can work with any distribution of OpenJDK. It detects vulnerabilities that are present or used, right? So, and this is the big difference for the false positives. So we cannot only tell you if you have a vulnerability, because this is the same that the security scanners up to CI/CD can do. We can tell you, because it's scanning in production, if you really called the vulnerable libraries or if you never called them, right? And that reduces the number of false positives, right? So we can get information down to the method level in that vulnerable library, right? Which is very useful, because usually it's just a method or two that are vulnerable in these libraries. So we can even tell you if you called this method or not. And then you can check vulnerabilities at runtime or at any given time frame. So you can create reports, let's say, from this point in time to that point in time, and then create a report for this thing. And to make it even more powerful, we added an API, and then you can use the API in your own tools, or you create your own tool or combine it with other tools and get the information from there, from the Intelligence Cloud via the API. So I give you a little demo that is, of course, it's not live because it's always demo gods, right? So I will give you some screenshots from the web interface, for example, that we use. So this is, for example, the Intelligence Cloud Azul Vulnerability Detection. And you see we have different parts like code inventory, component inventory, and so on. This is running in your instance of Intelligence Cloud, and then you see we have different reports. And the first thing that we do is we create a report here. And then in the report, we tell them, okay, from this point in time to that point in time, in this case, it was 3 hours. We create the report. Once it's done, we can download the report, and then we get something like a JSON file in this case, right? So we can see the component version. That means in this case, it was log4j core version 2.14.1. we see the base CVSS score, which is 10, which is very critical. And then we see also the CVE state. So that means if this one was used, so we really used it, and the component name, which is log4j core in this case. So this information you get in the JSON file, which is nice, but to be honest, yeah, it's not really, JSON is not really the format for humans, right? So of course we also have report details that you can see in the web interface itself. So that means you can open it up, and then you can see if the list, first of all, of the components. Then you see the component version afterwards, and then the score of the component or the vulnerability that was found. It's the CVSS base score, the CVE ID that is related to this vulnerability, and then if the vulnerability or if this component was used, or if it's just present. If it's just present, means you should probably update it, but you are not in danger right now. But if it's used, that means, yeah, you really should do something here, right? So the red ones in the CVE state list, this is the one in the column, this is the stuff you really should focus on working, which is quite useful. So it reduces the number of false positives quite a lot. So this is the web interface. So now if we use the API, I created a little client that does more or less the same, plus some additional parts, just to give you an idea what you can do, right? So in this case, I use JavaFX to do that. So you see it's very similar. So I have a list of all the CVEs related to the components with their CVSS score. And you see already I have CVEs present and CVEs used. So you can see, okay, there are some things that are just present and others that are used. To give you a little bit better idea, I also added the EPSS, which means the exploit probability scoring system, which is quite new. It's an AI-based method to figure out CVEs that might be exploited within the next 30 days. It's freely available, so I just added this information for each CVE. And also the so-called KEV, which means it's the known exploited vulnerabilities, and they are also stored in a publicly available catalog. That means every CVE that was exploited is in this catalog. So that means this stuff is really critical. So if you see one of these bubbles filled out with a color, like a solid color on the right side here, the 10, that means this is a KEV that was really, there is an exploit for this CVE. So this is really the critical stuff, okay? So back to the little client that I wrote. So the first scan that I did was I found 264 affected components, which is quite a lot. And you don't want to check all of them manually, but it takes a long time. So the first thing I did was, okay, show me the stuff that I really used. Oh, let's see. Oh, it's only 86 affected components, which is way better than 264, right? But still 86 components to check, still a lot of work to do. So the next thing that I did was I just said, okay, show me all of them that are known exploited vulnerabilities. And that brought the number down to 35 components that I have to check. And now I still can do one additional step and say, okay, now that I know it's 35 affected components where I have known exploited vulnerabilities, show me only the ones with a high score or critical score, right? So in this case, critical means from 9 to 10 in the CVSS scale. So that reduces the list further to 9 affected components. So that means these 9 components I really should check immediately, because there are exploits available for these CVEs and they all have a high critical score, right? So that means it's a score between 9 and 10. So they are really critical to my system and they are used by my application. So these 9 components I should check first, so that you get the idea, right? So I can better prioritize the stuff I need to work on first, and then step down to the other stuff that is not that important to check. You get also additional information like, okay, give me the distribution of all the CVEs that you found, and also the unique CVEs, because some CVEs will be found in multiple libraries, so stuff like that. And then you can export the list of the 9 CVEs that have been filtered by this client tool in a PDF, for example. So this is stuff you can do if you use the API. So you see, the API makes the tool even more powerful, right? But you have to spend some time to create your own client, or you can try to use the API with another already existing tool to get the information from Intelligence Cloud. So the conclusion is AVD can help you to find vulnerabilities in production without the performance overhead, which is quite important. So, and with this, because we can tell you the stuff that is not only present, but is used by your application, you can reduce the number of false positives. And that gets even more powerful by using the API, because you can add additional stuff to this data that is already available. And it helps you to prioritize on vulnerabilities that are really worth working on, right? Instead of wasting time to stuff that is not used at all. So with this, I'm done for today, and I'm looking forward to see you today at the next time on this channel. See you there.